Welcome to the Muxall Open IoT channel. I am your host, Michael Crane. Okay, so in this video, we're going to be taking apart this Pace MBT-250 Rework Station. It's a, there it is, says right there, soldering, desoldering, and rework system. So, unfortunately, ours doesn't look like this. Ours looks like this. And if you want to see the actual disassembly and assembly, that's actually in a previous video where I'm repairing this unit and I take it apart and put it back together. And the reason why I split them apart is because that other video was getting long, and I just wanted to kind of leave that as the previous video as, okay, this is how you take it apart and fix it and put it back together. And this video is going to be more of looking how it's constructed and what's inside of it, right? So, yeah, let's get started. Okay, here we go. So here's the front panel on the right here. And here's the main PCB. This is the base. And this base actually slides into a case. Here's the big transformer. This thing probably weighs 10 pounds. And here's the back plate. And we'll look at all these things here in a minute. But this is how it's basically put together. And this motherboard actually goes on top. So this is the top, and it goes right here. This is the bottom. Here's the front, and there's the back. Okay, and then the vacuum pump goes right here on these mounting studs. So we'll just take a look at these things. Here's the front faceplate that we looked at earlier, and here's the pump, and this is what we were repairing in the previous video. And I can show you real quick, maybe. Yeah, so you can see right here I added fiberglass because this plastic piece, let me see, yeah, here it is. Yeah, this is a good picture. So this is a plastic plunger, and this is a diaphragm for the vacuum pump. And this thing just kind of rotates, and it's like a fish pump, really, if you're ever taken one of those apart. But anyway, this thing rotates, and it moves this plunger in and out. And what had happened is, as you can see right here, it broke, and it broke down here. And this piece was just rattling around inside the inside the unit when I got it. And so as I glued this together, and then I added 2 layers of fiberglass on top of this thing to make it sturdy. And you can watch a previous video on repairing it. So yeah, and here's the motor, and this is like a counter. So this is a set screw slash counterweight, I'm guessing. It's so big. And I guess it's countering so you can see the shaft is offset in this brass piece right here. And I'm guessing this is the counterweight for this, so you don't get a bunch of vibrations going on from it being offset. And plus it's got a nice sealed bearing right here that it's mounted on. So it still makes quite a bit of noise and vibration, as you'll see in the previous video if you watch it, but I guess it works. And by the way, in case you're wondering, this thing sells for about $1,800. So yeah, it's and it's still this thing was built in the 90s, I believe. Here's some specs. We can look at it, this stuff here in a minute. Well, we can look at it here real quick. Well, ours doesn't have all this stuff. Is there anything interesting? 120, 230, sensitive temp, blah, 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 blah. Power supply self-contained, no shop air required. Just plug it in, woohoo! And low abrasive, dry white, I don't know what that means. So, yeah, so when I got this thing, a buddy of mine bought this thing used somewhere and loaned it to me. I think he wanted me just to fix it. But anyway, he loaned it to me and it wasn't working, and it was because it wasn't pulling enough vacuum. You can see the repair video. I don't want to go over it again. And here's the pump housing. So this is the other side of where the diaphragm is. I'm guessing it just has a check valve in there. It's got a V for vacuum, P for pressure. And here's the motor, and it's got here's the case grounding right there. And it's got a choke on the motor windings to help with the inductive kickback. And okay, here's the main PCB close up, and we can take a look at some of this stuff. I haven't looked up all these things. Look at the date code on that chip. 1986. Holy moly. Yeah, that's pretty good. So, yeah, and I just love how they hold this thing in the socket. I mean, that is classic right there. And let's see, is there another? I don't know what that number is right there. Someone signed it. And it's Rev in, it looks like. Let me flip this guy over. There we go. Pace Inc. 6020091. I wonder, 602, I don't know what that means. Rev in. Okay, let's take a look at this guy. Okay, since we started down here, here's the main chip. I didn't actually look this up. Let me see, do we have another picture of this that's a little better, where I can see the name of it? According to Google, it's a Philips microprocessor. It looks like it can have, where did I see it? Different, yeah, 4K, 8K, 16K. It says somewhere around here, oh yeah, acquired by NXP, so I guess NXP owns them now. I don't know if they still make this chip. I'm not familiar with it, honestly. Yeah, so it's just a little microcontroller. Let's see, what else we got going on here? Okay, and here we got the buzzer right here. This guy right here is this little buzzer. These are some resistor networks. I noticed, I looked up a few of these chips. I don't remember exactly what they all are. I could look them up again, but they weren't very interesting. They had some op amps and some things like, things like that. And so, you can look them up if you want to. I think these are op amps. Okay, this guy right here, this is a differential comparator. This ST Micro is a chip right here, is some Darlington transistor arrays. These guys up here are some op amps. And these are some CMOS analog switches. And, I was just sitting there thinking about that. I think I downloaded the service manual for this guy. We could probably just look at that. But I don't know. This isn't very interesting. I'm guessing these guys up here are some kind of triacs for turning on and off the power. I didn't bother trying to get in there and see what kind they are. I'm guessing these are optocouplers for the triacs. So these are probably switching some high current things, and these are the optocouplers for them. At least that's what they look like. And maybe we can get it. We'll see later. And we got some other transistors down here. And that one's completely covered up. Whatever that switch is right there, it's probably some high power. I don't know, it's next to these big caps right here. And I'm not really familiar with these Lelon caps. I Googled it earlier. I mean, they're sold at Mauser and stuff, so yeah, I guess so. And let's see what else we got here. Oh, but yeah, I forgot to say that, yeah, this is probably like some kind of voltage regulator, I'm guessing. That's clamped down in here in this heat sink. Not sure what that is. This looks like some kind of bridge rectifier. A couple of them. These are some big power diodes. And let's see, what else we got here? Oh, this part right here, in case you're wondering. In the previous video, this little clip right here broke, and so I put some super glue on it, and I'm using this just to hold it in place. And yeah, just this looks like it's the same thing. Another comparator. I don't know what this upside down part is. Tip 107. It's just a BJT upside down. And this is kind of nice right here. It's got 4 test points. It's got plus 12 volts, minus 5 volts, ground, and plus 5. So that's pretty nice. If you're having some problems with this board, you can check the voltages. Excellent. And that, I'm not going to look at the rest of this stuff. it's not very interesting. But that's about it. So let's see, what else we got here? Here's some more pictures. If people want these pictures, I'll be more than happy to put links in for them, post them up on the internet somewhere. Oh, here's the back panel. And this cal set unlock. We'll have to look on the inside of that. I don't remember any kind of knob in there. Well, that's interesting. I didn't even notice that until we started looking at it. Here's the model number and power requirements and all that other fun stuff. So I was looking at the serial number down here in this 0206 175. This just kind of looks like some kind of date code to me. I don't know if it's 2002 or 2006. My guess would be 2002, 6th month, and this is the number 175th unit they made. I don't know. That's kind of interesting. If anyone knows, they can let us know. We know this thing is pretty old. We could probably look for some more date codes on the chip. I think probably more on here, but okay. So here's the back of the front panel, the back side of the front panel. Wow, is that the date code on this? 1288. Yeah, this thing has been around for a while. Or maybe is this it right here? 98, 8th week. I don't know. Interesting. And here's the back side of the PCB, or the main PCB. Nothing very interesting there. Let's see, does this transformer tell us anything? No. Multi-tap. Here's the IEC connector. Oh yeah, so here, I've got a better picture of that. Yeah, here we go. Yeah, so here's where that cow plug goes, and I don't know where that thing would hit anything. We'll have to look at that. That's interesting. I don't think that goes anywhere. Maybe they used to have something there and they removed it. Yeah, I don't see any buttons. I believe, let's see. Yeah, so here's the assembly. So this is the bottom, this is the top. It mounts upside down over this transformer right here. And as you can see, the front plate's upside down. So this is the front, here's the back. Yeah, there's no buttons on this thing for it to calibrate. Yeah, I don't know what that's for. That is strange. Anyway, that's okay. Well, back to what we were doing. So yeah, this is the connector for the foot pedal. Yeah, that's pretty much it. There's not a lot to this device. There's a close-up of the transformer. That's it. That's about all she wrote. Well, I tried looking up this transformer, and the only thing I could find was this eBay listing for Electrical Windings Company, manufactured in 1980. This one looks like it's sealed, but it does have the EIA 682, which is what's marked. I don't know if you can see it right there. I walked over and took a look at it, but I thought I had a close-up of the transformer. Oh, here we go. EIA 682. All right. And that's pretty much all I could find on it. So yeah, it's a little bit old. And this one, I guess, was manufactured in 1980. Wow, kind of gives the color code of the wires. Not very interesting to us. We could probably get this from the manual, right? Okay, so let's take a quick look at the. here's the service manual. And we won't take too much time with this. It's not very interesting either. But yeah, I was looking at this before I was recording, and I was sitting there thinking to myself, wow, this doesn't even look like the unit we have. Maybe it's a newer model. And then I scrolled down to the date right here, and it's copyrighted 1998. Wow, this manual is probably older than the unit. I don't know. So anyway, we can look at this real quick. Like I said, there's not a lot of stuff in here. There's safety, general information, specs, calibration. Yeah, we might see if we can see what that calibration thing is. Key lock option. Oh, maybe that's what that is. It's that key lock option. Let's see, can we go to page 17? Nope. There we go. Ah, yeah, that's a optional key lock feature is available for Pace, which prevents unauthorized alteration of temperature and offset settings or Yeah, but I guess we need to back up and see how to calibrate the thing. Okay, so yeah, I was kind of looking around. I didn't want to bore everyone with me just scrolling up and down this thing. But yeah, so to enter calibration mode, okay, to enter calibration mode, you got to press up and down arrows at the same time you power it on, and then release after 3 seconds. So I guess that key lock option, I guess it just, if you have it locked, you can't hold that up and down arrow maybe to get it into calibration mode. So yeah, we obviously don't have it. It's an optional. I mean, all you'd have to do is unscrew it, right? Unscrew the unit to get past that. So that explains why we didn't see anything on the panel. Okay, so since this is a quote unquote teardown video, I guess we'll go through the disassembly and assembly instructions, okay? Follow these procedures. I'm not going to read the whole thing to you. We're just going to look at, unplug it from the power, remove 10 front panel mounting screws, okay? Pull the panel 3 inches forward, reposition the power source with rear of unit facing forward. What does that mean? Remove the single hex screws. There's 8 of those on the back. Pull the rear panel forward 2 inches, lay face down on work surface. Okay, take note of all the cable on the PC boards. Yeah, you can see how the main board is upside down in the case. Here's the bottom plate right here. Is the main board. It's upside down. You do not have to unhook all these connectors. This whole thing will slide out as one solid unit. You just unbolt the base plate from the chassis, and the whole thing will just slide out. All right. Then it just shows disassembling the. This is sliding it out. Like I said, you can slide the main board out with everything else. In fact, I found that easier. I didn't, as you saw on the table, I didn't disconnect anything. I left them, which is probably good because one of the connectors was so old and crusty it just broke when I tried pulling the connector out. Okay. Anyway, so here's a PC board, vacuum hoses. Nothing very exciting there. And here's the assembly. Well, you got to disconnect the AC power cord before you assemble it. Well, I sure hope you didn't have it plugged in while it was disassembled, but yeah, okay. Disconnect PC board, air hose connection, slide transformer. I guess this is if you were working on it on the bench maybe, right? Because it's now saying disconnect the board and air hoses again. So I guess they are expecting you to work on it on the bench. Ensure the rear edge of the transformer assembly plate is flush with the rear of the case. Okay, that's good information. Okay, make sure all the wirings connect, reinstall the front panel, and that's it. Wow. Yeah, that's pretty detailed. Here's some flow charts. Okay, no power, check fuse. I'm not going to read all this junk. I like this. Wiring okay? No. Repair wiring. That's great. That's classic. Let's see. System now okay? Yes. No. Contact Pace Service Department. They're all retired by now, I'm sure. Motor malfunction. Okay. Yeah, we don't care about any of this stuff. Digital readout. Yeah. Wiring diagram. Okay, well, this is kind of interesting. Here's the transformer T1. It's got all your color codes. That's nice. Here's the motor pump. Motor pump. See, I would have called that a pump motor, but anyway. Let's see. Here's the those DIN connectors and the wiring for them and the front panel switch. That's interesting. They're switching both the common and the neutral. I guess it's because it's 230 volt, supports 230 volt, maybe? That's interesting. Here's a main PC board. Let's see, what is this? Optional. Okay, here's the optional key lock, how it's wired up. So you can bypass it. If you lose your keys, you need to get in calibration mode. Self-contained air. Don't know what that means. I like this. If you have any questions or notice any discrepancies between this wiring diagram and the wiring in your Pace power source contact base. Okay. 85A wiring diagram. Oh, okay. I guess they have different models. 85 and 85A. Okay. I'm not sure what ours is. Doesn't matter. Same. Here's the main PCB assembly schematic. Okay, well, that's interesting. Okay. Anything interesting on here? Okay, so yeah, we can see here's one of those resistor networks. Power in. Here's those Darlington pair arrays. This is kind of interesting. It looks like it's a logic device. I'm not sure. I didn't go look this up. I just kind of Googled what the part number was and just called them Darlington arrays. Let's see. Pull-up resistor, oscillator for the clock, 12 megahertz. Here's some of those 3904 transistors. That's going to a taint. That's not good. LM339 op amp. Let's see here. What is that doing here? Oh, okay. So here's the. This is probably. I didn't Google this number. I guess I can do that real quick. Yeah. So this is a. I thought it was going to be a precision Zener, because it looks like they're using it for a voltage reference. So they've got the Zener. It's going to ground. Anyway, so this Zener. I didn't look up what the reference value was. I'm guessing it's probably around 2 volts or something like that. And who knows? Oh, 5.6 volts according to, I'm looking right here. You guys are wondering. It's only 5% though. I thought that was kind of interesting. And 5.6 volts with a 5 plus 5 volt supply. It doesn't make a lot of sense to me. But hey, what can I say? But yeah, I'm guessing this is a voltage reference. And it looks like they're going to some shunt resistors, I guess. To measure. I don't know why. I guess maybe that's what the comparators are for, to compare the difference. I really don't know. I'm not going to analyze this circuit. I don't really care that much, and probably not really qualified to do it anyway. So yeah, here's more of those resistor networks. Here's that big chip right there. Ooh. Okay, on the next page here. I got more of these Darlington relays right here. Here's a PNP transistor, 4403. Nothing interesting there. Oh, here's a speaker. A resistor network. Oh, here we go. 3904 transistor is feeding. Okay, so they're just using this as a switch right here. And they're feeding this optocoupler right here, MOC 3042. Let me Google that real quick. Okay, that's a non-semiconductor optocoupler, and it's going into this TO610BH triac. You can tell, and if you look at this, whoops, let me zoom in a little bit. The symbol of this looks like it's an opto triac, which is similar to what I use in the barbecue controller. I've been following along with that, and this is just a regular, because this is the triac symbol right here, and that's kind of blurry. I'll back it off a little bit. Anyway, there's 3 of those, probably for the 3 hand pieces, right? And is that it? Let's see, what is this stuff? Yeah, looking at this. So here's that voltage reference. I guess this 0.6 0.6K? I don't know. It has little dots next to it. I'm not exactly sure what that means, but I guess this is how they're. And these are op amps. This must be like how they're sensing the temperature inside the iron, I'm guessing. Yeah, like I said, I don't really want to. So here's the reference, but it had an unregulated feed too. I don't see that. Maybe that's going somewhere else. But yeah, let me check out, see what these two chips are real quick. Okay, so I Googled them real quick, and this TL500C is a A to D converter, and this DG212CJ is a Maxim CMOS analog switch. I guess it's got 4 of them in there. Quad, single pole, single throw, CMOS analog switches. Okay, so yeah, I guess this is they're turning it on and off. Iron mux, external mux. Yeah, I don't know. Interesting. Okay, and they probably need the precision reference. I'm guessing they're feeding a voltage into. Oh yeah, you can see it right down here. So these RTDs, so they're feeding a known voltage and current into these RTDs, and they're measuring it on the other side with their precision reference, and they can get a good idea of the temperature of the tip. So that's exactly what this is for. As soon as I saw this RTD, I knew exactly what it was. Whoops. Oh, where'd we go? And I think that's it. Sheet 3 of 3. Oh, we've got more. Okay, and here's the front panel, the foot switch, and chassis ground. Okay, these just looks like they're going into a bunch of logic gates here. It's probably like, okay, if you push the button on the front panel, it needs to do this and do this and do this. It needs to turn the vacuum pump on and blah 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 blah. And foot switch does kind of the same thing. It looks like, and I'm guessing that's just making sure it's in the right state to turn everything it needs to on to turn the motor on. I'm guessing. That's kind of what it looks like, though. And this down here is just the power supply, all the different taps, where they're going. Oh, these are probably the voltage regulators. Here's the bridge rectifiers we looked at. Okay, there's the 2 of them that we saw. Yeah, so these are positive temperature coefficient thermistors. They protect overcurrent. Okay. Those got a little bit of protection in there. We actually didn't look on the board too much, did we? And here's a 85A. It's probably the same kind of stuff. We won't go through it. I think we've got a good idea of what's going on there. Here's a display PCB assembly schematic. Not very interesting there. Some switches. The air hose routing. Here's the Visi filter. This is interesting, it's inside the case. I'm surprised they just didn't leave it on the outside. But I guess this is like a protection in case you forget to plug it in the outside. And here's a power source replacement parts. Motor pump assembly. Oh, here we go. Oop, anyway. Okay, what is all this stuff? Replacement parts. Accessories. Okay, calibration kit. Foot pedal. All right. Not very interesting handpiece stuff. Replacement parts for the handpieces, and that's it. That's the bottom of the page. So, I think I'm going to call an end to this video. This has been somewhat interesting, although not too unexpected. I am surprised how old everything is. I thought since it was still for sale, I figured this would have been updated several times, but it's still from the 90s, so there you go. And that's about it. By the way, just so you know, I found some replacement parts for this thing on Jensen Tool Supply. They seem to have a pretty good selection. Here's a diaphragm kit, even though these diaphragms don't look like what goes in the one that I have, and this pressure knob assembly, and here's the same kind of diaphragm. This is kind of interesting. It's this O-ring right here is what I have. This must be for what's inside the the piece that that we have. So this is I in the previous video I kind of boogered this thing up, but look at the price of this thing. Whoa. Yeah. Yeah, so for $306, I'd probably just buy another rework station. For sure. Yeah, maybe one that was built in this decade, right? Okay. I'll see you guys later. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.